Hey, this is Horner, and this is the 1996 B4 video solution. And this question says you have a 12-volt battery, and it's hooked up to 4 resistors that are 100, 30, 20, and 10 ohms each. The student has plenty of wire and just very little resistance available to make the connections. Using all the components, they want us to draw a circuit diagram in which the resistor has a non-zero current, but in which the current from the battery is as small as possible. Anytime you have anything that you want a small current, we want to do this in series. So series equals, and then this would be small current. Now that we know that, we need to go ahead and draw this in series. So we'll draw a battery, go over to our first resistor, to our second resistor, third resistor, and finally fourth resistor, and then back down, and back over again, and then make sure that you label each one of these, 100 ohms, 30 ohms, 20 ohms, and 10 ohms, and our battery is 12 volts. Using all the components in the second part, it says draw a circuit diagram in which each resistor has non-zero current, but in which the current from the battery is as large as possible. So in parallel, we would have a very large current. That means that we need to draw this in parallel, which is pretty easy to do. We're just going to draw our battery. And then I found it easy to just make one line like this, and then make another line coming over and going down, and then drawing each one of your resistors. So here's 1, here's 2, here's 3, and finally here is 4. And this will be 100, and then 30. This one is 20 ohms and 10 ohms. All right, let's go ahead and take a look at the back side of this. It says we have the battery and the resistors now connected, and you'll notice that now they're in a circuit, and this is not just a series or a parallel, this is actually a combination circuit. So for this combination circuit, I think the best thing to do is to actually create a Verte table. So we're going to create a Verte table for this one, but we're only going to do what we absolutely positively need to. So we're going to do V, I, R, and P, and we have our resistors. And so our very first resistor that we have on this one is our 100 ohm. The next one is our 20. Then we have our 30, and finally we have our 10. And down at the bottom, our total voltage here is 12. And so we'll just put R100, R20, R30, and R10, just to help us double check as we go across. For the total resistance, we need to go through and do all the serial stuff here. First, since this one is the very inside of the circuit, we'll do it first. We'll go ahead and add these two together, and you should get 50. And now we've got a parallel branch, so you'll notice that the two serial come together into one and make a parallel branch. So this is 50, this is 100, and we need to find out what is the resistance in this branch. So let's go back, do the resistance in series we know was 20 plus 30, and that's equal to 50 ohms. 1 over the resistance in parallel that results is 1 over 100 plus 1 over 50. 100 comes from here, the 50 comes from this being one thing now. Our common denominator is 100, and this is 2, so this would be 3 over 100, which when we find the parallel resistance then should be equal to 100 over 3, which is equal to 33 ohms. And then we can find the overall total resistance, since we now know this whole thing is 33. 33 plus 10 is going to be what we need to do in the end, so we add that to 10, and we get 43 ohms for the whole thing, and we'll write that in right here. So we have 12 volts, we have 43 ohms. They want us to find the current in the 10 ohm resistor. Before we do that, we need to find the current in the whole circuit. So the current is equal to the voltage divided by resistance. Voltage is 12, resistance is 43, and we end up with 0.28 amps. So this is 0.28 amps. And because this is in series, we know that it is also 0.28 amps. So that is actually our answer. Last thing we need to do on this one is just solve for the total power consumption. And power is equal to current times voltage. So that would be our 20.28 amps times our voltage of 12. And that will be equal to 3.36 watts. And that is the end of this very short question. You do not need to do the very bottom part. And that's it.